Fellow St. Lucians, this is Openmike, and we are now coming to the third segment of our program. When we left off, we were revisiting the height of the riverbeds coming down from the Bog Hill, going through Bexar, and eventually finding its way down to the Cul-de-sac Valley. Now, as we all know, that as the rains come, we have a lot of infrastructure, and I talk from experience because being a shareholder in CFL on two occasions, which is Thomas and the Trough, the company experienced pretty close to $15 to $20 million in damages, and which is a very worrying factor. Apart from the height of the river coming down from that area, there is a huge drain running parallel to the Debole warehousing, which has not been maintained. As a matter of fact, twice while I was deeply involved into the CFL, I've had to bring in private contractors to desilt that drain, and on both occasions over 90 truckloads of silt were taken away. But what I did observe close to the Texaco gas station at the Super J's, Mega J's, where the Big J's warehouse was, the culvert there is quite small. The company, in fact, had built a very substantial drain to the east of our property, which handles some of the water coming from the cul-de-sac area. But what happens is the amount of water that is coming down, it goes over the land, and that makes a mess of everything. And you know, that's a very costly exercise for private investors. And I know the government, they lack the funds to do these things. But I always was of the opinion that using huge excavators and backhoes to desilt a river, if you take it from the bottom of Bardell Hill down to Bexar, it's quite a distance. And when you're looking at 3 feet high, it's a lot of silt, and there are two schools of thought. One, what is the quickest way to take it out? And secondly, where does one put all that silt? I'm going to ask the former engineer, chief engineer, a question which has been on my mind for quite some time, and that is, despite the astronomical cost of bringing in some formidable equipment whereby this mud can be actually sucked out and placed somewhere else, and I'd ask him to give me his views on that.
Okay, I'm going to answer two of your state comments you made. The first one, where you indicated that the culvert crossings in cul-de-sac might be too small. The thing is, in engineering, when we design, we make certain assumptions during the design process. Now, at the time when those culvert crossings were installed, there's something in the designing of a culvert crossing or any channel, open channel, there's something called runoff coefficient, whereby you look at the amount of runoff you're going to have from your surrounding area contributing to that open channel. So in the days when those culverts were designed, what you might have found happen is that the development or your runoff in that time was not significant, and it might have been, say, 30%. And over the years now, once you have development taking place, your runoff increases. So now you might be up to 80, 90%, 100%, who knows? But I'm just saying.
Yeah.
So it is something that in designing, you make certain assumptions. And if you were to design for 100% runoff, it now means that your culvert crossing will be a lot bigger to accommodate the flow that you're looking at. But it would also mean additional cost. So you try to strike a balance between cost and designs at the same time.
Okay.
So at the time then, what was done was the balance was struck of runoff vis-a-vis the cost of those culvert crossings. Now that you have additional runoff, it now means that you'd have to go back and redesign those culvert crossings. And it is something that, and like I indicated, It is being done for all of the major bridge or culvert crossings in and around St. Lucia. So you find now that some culvert crossings might be increased from, say, an 18-inch culvert to a 36-inch culvert, or whatever the case might be. The same thing is being done for the Broadway Bridge. The Broadway Bridge, you had 4 AMCO pipes. I can't remember the exact diameter of them. But when you look at the cross-sectional area that they provided, vis-a-vis what is there right now, the cross-sectional area that is being provided by the new bridge is going to be about double or more of what was there before. So these are the things that you have to look at. With regards to the siltation of rivers, like I indicated, you have a lot of silt upstream that is waiting to come down. And you rightfully said, if you take it out, if you dredge it out, where do you put it? One of the things we did in the Bexar area was that a lot of the material that was taken out was actually placed on recreating the playing field in that area.
Okay.
So it is something that you have to look at, because trying to truck out all of that silt is costly.
Costly.
If you try to do like a dredging format, a suction dredging, the question is you might not have the equipment might not be available locally, and you have to source it internationally. 2, you might need a barge to bring these things upriver, whatever the case might be, and do we have sufficient draft within those rivers, or in terms of flow, to accommodate a barge coming up? That might not be possible. So you find that the most sustainable form of desilting those rivers with the use of excavators.
Okay.
Now, because of the amount of silt that we have upstream waiting to come down, desilting has to be an ongoing, very intensive exercise has to be done for the next couple of years, 5 to 10 years. Mm-hmm. And just to give you an idea of the amount of silt that came down during the hurricane and is waiting to come down still, I'll give you 2 examples. One is the Canaries area. Mm-hmm. If you look at the mouth of the Canaries River right now, mm-hmm. an island is actually forming. Okay, it's like a delta. Yeah. And if you remember geography, it indicates a delta is the formation of the deposition of material at the mouth of a river, where you find the velocities of the river slow down so much that you find deposition taking place of all suspended particles within the water. So you find now that all of the material that has come down from the upstream area of the Canaries River is being deposited, and that is expanded on the bulkhead of in that river. There's still a lot more material to come down. It's a very sandy material.
Now, when you say there's a lot more to come, where is that silt now? It's still sloping upstream.
Still upstream. Because
and like it hasn't come down because it's being blocked?
No, it's not that it's being blocked.
What?
Because of the mass and the volume of that silt.
It's coming down in sections.
Slowly but surely it's going to be eroded.
Okay, right,
and because it's a sandy material, it's not consolidated very, very quickly. Mm-hmm. So you find that every time you have a heavy rainfall, or any bit of torrential rainfall, mm-hmm. that material will be slowly eroded and it will be deposited in the lower reaches. And that is why if you watch the Canaries River over a 1-year basis, mm-hmm. especially after the silting exercise, mm-hmm. you would see there's a gradual buildup of material in the river, especially from where Wasco have the pump station.
Yes.
Coming back to the river. Mm-hmm. You'll see that happening. The same thing is happened in the cul-de-sac area. Mm-hmm. If we remember clearly, there was a nice little bay in the cul-de-sac area, but immediately following the passage of Hurricane Thomas,
yes,
that the beachhead was actually shifted outward.
I saw that. Yeah.
A lot of material was deposited there, and you now have, in excess of 15, 20 feet or more of material was deposited on that shoreline. And it even went out further into the bay, to the point whereby it has affected, to a certain extent, the maneuverability of ships within that area. Yeah. Now, that area is going to continually grow because of the amount of material.
The water going,
exactly, because of the material to become down, it's going to create things. So you find now that once you have that buildup of material in the river crossings, you have a reduction in your cross-sectional area of the river, which means that you have less carrying capacity, and any water that you have coming down in excess of your carrying capacity will result in flooding.
So, I was paid a lot of attention when Hess was dredging that the for their project. And now that we have Buckeye there, you think that it's worthwhile that government should talk to those people because they can afford it in a certain way over a period, because there's a throughput charge, to assist us in taking away and desilting that, because that's going to be a big problem for us in the future.
Well, it will be. I mean, I think Slasper has that problem also with the Castries River, especially down by Shed 6.
Yeah.
That river comes out and all the debris is deposited there. I know some time ago it was they desilted that area and a lot of money was spent.
Yeah.
But can we sustain that level
we
of operation
cannot.
every time? So it comes to the question of finding sustainable solutions with all of the relevant stakeholders, because government alone cannot do it.
They cannot do it.
Okay, I mean the resources, financial resources is just not there.
Not there. Tell me something, Lester. 20 years ago, I was a director of Slasper, and we were already having the problem because we had several, complaints from the banana boats when they were using that shed there, because we would have 45 feet of water, and believe it or not, within, say, 10, 12 weeks, there was 10 feet. It went to 35 feet, so 10 feet of silt coming off the Castries River. And I mentioned to Slasper then that what they should do is get a cherry picker, and every Monday morning, you dig a silt trap, say 12 to 13 feet deep at the mouth of Castries River. And you know, you actually can give it out and contract it out, and you can actually sell that stuff as topsoil. Now, I know right now, between Thomas and the December crop, these were very unusual times. But as you said earlier, it has to be an ongoing exercise. Yes. It cannot be something that, because the government can't afford, no government can afford to do what they're doing there. So, in other words, but the question I just posed to you, does it make any sense, or that's impractical, what I've just mentioned to you?
The thing is, I mean, you can have a solution for anything.
Yeah.
The question is how much you're willing to spend.
Yeah.
Okay. To have a cherry picker, yes, that can work. The only question is that it might not be able to use that topsoil, as you say, because you'd have, since it's a saltwater environment, the salt content in the soils will be very high for that area. So it is left up to the technical minds to revisit that. To revisit a lot of these situations.
To see what
and to see what can be done within the ambits of the financial resources that are available.
Fellow St. Lucians, this is Openmike. We have reached the end of the third segment of our program, and we'll be right back.